Yeah, page 51. So yesterday we covered these formulas, which are often used to solve for missing angles on polygons. Okay, and the letters tell you what they're seeking or what they're finding. Okay, so exterior, central, interior. Ice you can identify. Sum of angles you cannot, and diagonals I would argue is very difficult to do. Okay? We calculated, we used all the formulas yesterday on this pentagon here. Diagonals, guys, what that means, I'm kind of, I used up too much room, but here's what I'm going to try to do it here. Just for the pentagon, I'm not going to do it for any of the other ones. Okay, I'm going to try to use this space here. I know it's a little messy. Can we try to draw a pentagon? So basically you just draw like the roof of a house like this, and then you just go slant, slant, and connect. And I'm going to use 2 or 3 different colors. But a diagonal, if you count, we just calculated that 5 diagonals are possible. So you go from this corner, let's count. 1, 2. So there are your 2 diagonals. I'm grabbing a different color, maybe a blue pen or a highlighter. Then I go to the next corner. You can't connect there because they're already connected. So this would be 3, 4, and then I'm using a highlighter for the 5th one. The 5th one is right here. This is the only one that hasn't been drawn yet. So there are 5 diagonals. You can calculate how many diagonals can be drawn in that shape. So imagine once you have more, there could be hundreds of diagonals. Good luck drawing those, right? Like you could miss even one, you'd be off. So that's what we just did. When you calculate diagonals, when you do the D formula, you're figuring out how many diagonals are possible inside that polygon. All right, guys? Okay, I want you to go to 52. Go to 52 here with me. Can you identify ice? It's 3 marks. Put an I where the interior angle is, 1 interior angle, put a C where 1 central angle is, and put an E where you have an exterior angle. 3 marks. Honestly, even on a provincial exam, they would probably give you 1 mark just for identifying where it is. Okay, so I'll give you some time. It shouldn't take you longer than a minute, to be honest. If it takes you longer than that, you've been sleeping in my class. How dare you? Have you all identified ice? Do you guys listen to Ice Ice Baby? Is that something you would have listened to at some point? Yeah, you're not too young. Okay, that was big when I was younger. Anyways, I like the central. Like that one is the one that most students get confused by, and I honestly, it just go to the center, pick any of the sides on this thing. Don't do this. This is not a central angle. Don't copy this right now. That's not a central angle, correct? Because you're spanning 2 sides. This is a central angle right there. This is central. This would be another central if you wanted to. You have a bunch of central angles, but you just need to identify one. Let's count the number. Oh, I'm rushing here. Interior angle, anywhere on the corner, go and put an I there and make like a little arc right there. That's your interior angle, 1. And then you just grab this side and just keep extending it. That is 1 exterior angle. There you go. Ice is identified. Let's count the number of sides. Anybody done that already? I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N is equal to 11 sides. Okay. I want you to calculate all those things that you're able to calculate based on this information. So sum of interior angles, so just use the formulas on 51. Can you just use the formulas and just get an easy mark, right? I need you to be able to do that. So go ahead and calculate them. Use your space wisely. You don't need to write the formula before you start solving. You can just show me how you plug it in and go, okay? So take a few moments, and we're going to progressively get a little harder. I know I'm pushing a bit too much here, but I noticed that my time is running out. If you want the sum of all the interior angles here, use this formula. Sum would be 11 minus 2 times 180 degrees. 11 minus 2 is 9 times 180. And that's a lot, right? But it is, don't let that throw you off. That's the sum of all the i's in here would be 1620. Okay. To find the interior angle, guys, you can actually go 1620 divided by 11. But if you want to use the formula from scratch, this is it. Don't forget about the divided by 11. So that's 9 times 180. So 9 times 180 divided by 11 be 1620 divided by 11. So I'm just going to go ahead and divide the 1620 by 11, and I get 147.27 degrees. That's I. Okay. This is sum of all interior angles. This is just one. Each interior angle on this shape would be 147.27. Each of the eyes all around, and there's 11 of them, would be 147.27. That's I. For central angle, this one central angle, you just take 360 divided by 11. Yeah, thank you. 3273 degrees. That's central. Exterior is the exact same thing. The exterior angles always add up to 360 as well. That's 3273. You notice what do you think these two add up to? Interior and exterior are always supplementary, right? They're right next to each other. So we expect it, right? So you can say, or exterior angle would be 180 minus the interior, which is 180 minus 147.27. That's 3273. You could have used either or. Okay. And last but not least, the diagonals. Yikes, I'm using too much space. I'm notorious for that. It's n times n minus 3 divided by 2. If you get a decimal on these ones, you made a mistake on the diagonals. It has to be a whole number. So 11 times 8 divided by 3. Oops, see, I got 2933, so I made a mistake. Oh, it's divided by 2. Yeah. There you go. How did that 2 turn into a 3? No one knows. 44 diagonals. Can you imagine having to sketch 44 diagonals to figure that out? I wouldn't want to do it. Okay? But you know that there was a mathematician at some point in history doing that, right? I wonder. So like 15-sided, 16-sided, 17-sided. Right? So the same with a 30-sided. So how about I just say homework would be page 52, whatever is left. There's one curveball there, which I'm not going to tell you about. You spend quite a bit of time on it.